Hi, welcome to Tech Lesson 18. In this lesson, we are going to deal with family or firewall family Inet filters, specifically ICMP issues that occur within ISP networks. And what I mean by that is that we need to reject certain ICMP packets. The reason being is anybody who might be on a CPE here that wants to do a trace route out to the internet here, if we don't block them being able to see our internal IP address range, they will see it during the hops, okay? And we can't allow that. So what I've done here is I've opened up this one. I haven't got anything listed here, so I'm going to do it from here through to here and show you why there are issues with a traceroute command, why there are issues with an MX on certain interfaces, and why we would use a loopback interface rather than a physical interface. Okay, so without further ado, let's get on to the LNS and the CPE and see if we can initially get connectivity across to here. Okay, so let's do that straight away. So we'll go on to the CPE. We know the IP address for the London LNS is 1.1, 192.168.1.1. So let's do a run ping to that, make sure we can communicate with that. Oh, my apologies. Okay, and we can. And we'll be able to trace route to it as well. Let's do a quick trace route. 192.168.1.1, and we'll do we'll pop a no resolve in there. Okay, this should go through. It's just going to be a little bit slow simply because of the resolution and the fact it's going across bridging. Okay, but it will go there, so we will get communication down to the 1.1. There we go. Right. Okay, so that's to prove that we have the connectivity across. So now we need to go to the LNS. So we'll go on to the LNS. Now, we've got two ways of doing this. We can either do it dynamically or we can do it manually. Dynamically gives us a bonus in the fact that any interface changes we make or any additional interfaces or any IP address changes we make will dynamically be updated within this filter. It does not have to be manually updated. Okay, so first of all, let's put that in place. So we're going to do a set policy options. Okay, and we're going to do a prefix list. Okay, and we're going to call it something intuitive. I don't know, MX interface IPs. Okay, we need to apply the path because it will be calling the subsystem, which is obviously based around Linux FreeBSD. So let's open up speech marks interfaces. What interfaces do we want included? We use the wildcard within the left and right arrows, so lower, less than and greater than arrows. We're going to star it because we're utilizing wildcards. That means all interfaces. Unit. So these are the sub interface numbers, and we want all of those included as well. And family Inet address. That's IPv4. It would be family Inet 6 if you wanted it that way. And we want all of those as well. So let's pop those in there. Okay. So that's that side of it completed with regards to that. Now we can go ahead and commit that. Okay, that's our prefix list ready. Now we're going to set our family filter, our firewall family Inet filter, and we'll call it something intuitive. And we're actually going to the first line, the destination. Normally we would say something like destination address and then put an address in. Now that's the manual way of doing it, but I've just said this is an automated process. So all we've got to do is call the prefix list that we've just created. So we're going to go ahead and do that now. So set firewall family Inet filter. Let's call it something intuitive, and let's just call it ICMP-reject. Now the term itself as well is like another variable. Okay, so we're going to go term, we'll just call it 1. It's an easy way of distinguishing the list. So from, remember I said normally we'd put in here destination address, but we're not going to put in, because we've created a prefix list. Prefix list, and what's the prefix list name? There it is there. That's what we called it. So that now will automatically and dynamically update this filter list. We don't have to manually do anything anymore with it once we've configured it, of course, the first time. So let's use the up arrow. So from, okay, so from protocol, what protocol do we want it from? Well, we're doing ICMP, so it's ICMP, ping, traceroute, okay? What subset, so what type of ICMPs do we want to stop? Okay, well, we're going to stop. First of all, we've got to put ICMP type, and we're going to do ICMP-request. ICMP type, sorry, it's not an ICMP request, it's an echo, of course. Echo request and an echo reply. And we are going to discard these rather than reject, and the reason we're going to discard them is because it does it silently when it discards. So it gives the user no inclination that anything is wrong within our network. It doesn't give them any information back like timeouts or anything like that. If you use reply, it does. So discard is silent, reply is not silent. Okay, so we're going to discard that. Now, I said to you that Traceroute is sort of a little bit special. It's a little bit different. So what we've just done will work for ping, but it won't work for Traceroute, and that's because we have to give it port numbers and TTLs because of the way MX is and the way different line cards deal with Traceroute itself. Okay, now depending on what you're doing a Traceroute from, depends what port it's from. So if you include all the ports that I'm about to give you, from a UDP perspective, it will cover wherever Traceroute comes from. Okay, so from protocol, it's term 2 now, UDP, because it's a different protocol we're using, so we need a different term. And if you remember, I said ports or port. So 33434 through to 33689. Okay, those are the ports that we're going to do it from. And again, we want to silently discard, so that's what we're going to do. Okay, so let's do a silent discard there. Okay, now because of the way Traceroute works with its reduction of a TTL, it's never going to hit what we're going to give it now, which is TTL 0, TTL 1. It will always be one of those more than likely. So we give it that and we say, well, we're going to discard that as well. That covers all forms of Traceroute at that point in time. So we're going to give it term 3, okay, from TTL, I'm going to say 0. So that's time to live, and a TTL of 1. Traceroute, on every hop that it goes across, it reduces the TTL by 1. Okay, we are now going to discard this one as well. Okay, now we can do a commit check on that, and we'll commit it, and we'll do a run show configuration. And we'll do a display set. Okay, so there we go. So there's our policy options and our prefix list there. And there's our firewall filter. Now, how do we know what interfaces are going to be included in that filter? It's a very good command coming up that I'm going to give you now. Okay, so it's show policy options, and we're going to do a display inheritance. In other words, we want to see what we're inheriting and where we're inheriting it from and where it's putting it. Okay, we've only got the one set up at the moment, so we know, look at our interfaces. 1.10 is part of the 8/30. There you go. We didn't tell it that. It's done that dynamically. 12/12/24. 12.0/24. Correct. Okay, and 254 in there, look, and there it is there. So it's done that dynamically. We've not told it to do that. There's nowhere in here that we have told it where to do that from, other than here where we've asked, take this and pop it. So take this, populate this, and put it into here, which links it into here. Okay, now, normally what we would do at this point in time is, if we just wanted to protect one system, we'd apply this to the loopback interface. Okay, now I'm going to show you what the issue is with regards to the loopback interface. So let's go ahead and set this. So we're going to go set interfaces, hello 0, unit 0, family, Inet, filter, and we're doing an input, and we called it ICMP reject. Okay, so there we go. We've put that on there. We're going to commit that. Okay, and this is all on the LNS. So now if we go back to the CPE, okay, and we do this is the issue. 192.168.1.1. Okay, so even though we applied that on the LNS to the loopback interface, it does not stop any pings to any other interfaces, because we're not, if you remember the inheritance command we used, okay, that's all we're protecting here. That is it. So the 1.0 network isn't in there, the 1.0/30, so therefore I can ping it. But watch what happens if I try and ping .9. Let's see what happens if I try and ping .9 from the CPE. Okay. Okay, 1.9 we can ping. What about 1.10? Because I actually think it's 1.10 that's on that system. Okay, so 1.9 is actually on the core. That's why we could ping that, because it's not on that system. But 1.10, which is on that system, let's have a look. 1.10, which is on here, we cannot ping. And we'll never be able to, because it protects it. It protects the routing engine. Now, if you notice, we don't get any information back. We're getting nothing back. That's because we used a discard. It does it silently. It gives no information back to the user. So if we're trying to be hacked or some unauthorized access, we're giving them no data back with regards to what's happening. Okay, so we also will have a similar problem with Traceroute. So if we do a run Traceroute 192.168.1.1, okay, we should be able to trace route to that address. So we see the first hop. It may be a bit slow because of the no resolve. We see the second hop because it's a 1.9. We're not going to 1.10. We're going across it. Okay. If it was 1.10 that we went to, we would more than likely, actually, we would probably see that as well. We can try that now. Let's go to 1.10 and let's see if that allows us to see 1.10. Okay, so it's protecting 1.10. However, it's not protecting anything else. So for a singular system, this works fine. but it doesn't work fine if you want it to be committed across other interfaces on a route within your whole network. So you would have to put this on every router. Or what we can do is we can say, well, we could leave it on there to protect the routing engine on that system. Or if we want to just do this with one command, the interface that we would normally do it on would be from the internet into here. But like I said, I'm doing a replication of that across here. So the interface we need to put this on is the equivalent of this one here, G003. In this case, GE002, and it needs to be input because it's going to be coming in. Okay, so we're not going to do it on the loopback. We're going to put it on here. But we have to add an extra command to that. Okay, and I will show you what that is now. So if we go to the LNS again, the first thing we need to do is we need to remove the configuration from the loopback interface. Okay, so we've got the loopback interface. We are on the LNS here. Yes, we are on the LNS, and we set that on there. Yes, we did. That's because I haven't done a show configuration again since. So let's have a look a minute, and then that'll be on there on the loopback interface. There it is. So we need to delete that. We need to remove it from the loopback. So we're going to do that now. Let's remove that from the loopback interface. Okay. Let's commit that. Okay, now what we're going to have to do as well, okay, is because we need to include the whole network range that we want to not be allowed, okay, to not allow this echo request and echo reply, because in here, remember, this command will only give us our local information, okay. We've already seen that, so we can have a look again. It's our inheritance, okay. So let's have a look at our inheritance again, and you'll see it's all the local. Yeah, okay, so this is just local. So what we need to add in here is another destination, but destination address, and we'll utilize the network. So we can copy this, look, all the way through to destination, and we'll do address, and we're going to do the complete internal network. Okay, that covers the whole 4/30 range that we're using. So we'll commit that. Now, instead of applying that to the loopback, we are now going to apply that to the GE002 interface, this interface here, as an input. Okay, so let's go ahead and do that. So set interface GE-002 unit 0 family Inet, filter input, and then we're going to input our ICMP reject. Okay, we're going to commit that. Let's just commit that. Okay, so let's have a look now at our configuration. Okay. So now we've got our destination address as well from destination. Okay. All right. So let's go back to the CPE and we'll do a run ping. We'll do it to the 10 first. 1.10, and as you can see, we get nothing coming back. Okay, so what happens if we do a 1.1? And that's because we've included the complete range within that filter. Okay, so that's not going to come back no matter what we put in there. Now we can put 9 in there as well because it includes the whole network. Okay, and we won't get a response from any of it, and it's all silent as well. Now, what happens if we do a trace route? So let's do the run traceroute command again, and we're just going to go direct to 192.168.1.1, and I would like to hope that we will see just stars coming back with no information given. Okay, we should see no hops at all with regards to this, and this is how we can hide our network. Now, the only caveat to that you will have is when you're utilizing on the LNS, and we'll see this when we build it up a little bit further for the CPE and the LCP PPP communications. What we'll see is that the gateway address that's utilized is the loopback, and we can't protect that from a trace route. So what we're going to do, and what I'm going to show you how to do, is to falsify an IP address on there so that we are utilizing a correct gateway address, but when the user does any trace routes or anything like that, they will see a completely false address. They will not see the actual gateway address that we give. Okay? So I'm hoping that lesson has taught you a little bit about ICMP and how to put filters onto interfaces. So if you put it on the loopback interface, it only protects the local system. That might be okay in some cases. For example, an SRX or something like that, that might well be fine. But if you want to protect the whole complete route, then you need to put it on the incoming interface from external sources. Okay, and you need to include the networks that you want to hide with regards to that. Okay, so that's the difference. Loopback local, physical interface, complete route. Okay, if you do have any questions with regards to this, because it is a little bit complicated to understand the trace route side of things, especially if you're the same as me a few years ago that believed Traceroute just simply used ICMP. Well, it doesn't. It's all dependent on how you're utilizing it and where and what system. Okay, so just let me know. All right, okay, thank you for listening to this lesson, and we'll continue with some more filters in the next lesson and show you the danger of accept commands. Okay.